How's it going, everybody? Thank you guys so much for stopping by. My name is Tyler, and today we're going to be having some fun with tiny whoops. Specifically, I'm going to be upgrading my Happy Model Mobula 7 1S from the PH 2.0 battery connector to the BT 2.0 battery connector. Now, for those of you that are unfamiliar with the FPV hobby, FPV standing for first person view, it's where you fly drones with the goggles on. It's kind of like you're flying a drone in a video game. Tiny whoops are effectively tiny little quadcopters, no smaller than a couple of inches large. A really great way to get into the hobby. They're durable, they have these plastic frames. You can crash them over and over and over and over again without them breaking. They're cheap to buy, don't have to repair them much because of how durable they are. And you're also able to fly them inside with very little risk of breaking the quad or the things in your home. So they're great for flying out of season during the winter time when the weather's cold, or when you're just getting started and don't want to fly outside. So in this video, I'm going to give you kind of a walkthrough of some of the differences between the old standard PH 2.0 connector that's been used on these tiny whoops and toothpick style drones in the past, and the differences with the new BT 2.0 style connectors, why it's better, and what some of the drawbacks are. I'm also going to walk you guys through exactly how to get your quad set up to run these batteries, along with if you have any parallel charging boards or any of those charging accessories. I'll walk through how to get those situated too. There are a few different things that you'll need, including connectors, battery leads, things like new batteries, all that kind of stuff. I'll have all that stuff linked down below in the description, so if you guys want to take on this project too and get your quad upgraded to the BT 2.0 battery connector, you guys will know everything that you need in the description below. In the past, tiny whoops have used the standard PH 2.0 battery connector, and while it served the community and the hobby quite well over time, it wasn't necessarily designed to handle all the power that these tiny whoops are now putting out. It was designed more for use in radios and some other small electronics. The new BT2 connector, though, was designed by Beta FPV specifically for the FPV hobby, tiny whoops and toothpick style drones. Therefore, it performs quite a bit better than the PH2 connector that's been used in the past. When looking at a quad, every connector that you have between the battery and the motors is going to introduce some resistance. The less resistance you have, the more power actually gets to the motors, and therefore the better the quad performs. The amount of resistance is based on a couple of things, but one of the big things is the overall surface area of the electrical contact points of the connector. Now, I don't want to bore you too much, but I figure it's worth noting why the BT 2.0 connector is so much better than the PH 2.0 connector, just so you can get an idea of whether or not it's worth actually upgrading your drone and buying into new batteries and that kind of thing. So you can see the differences in connectors if you look closely. The prongs on the BT 2.0 connector are quite a bit thicker, and the other end of it has more metal contact space. So the overall surface area where the BT2 connectors connect is quite a bit more electrical contact surface area than the PH 2.0 connector. Get FPV actually wrote an article on this a while back. They mentioned that a standard PH 2.0 connector has an electrical contact surface area of around 8 millimeters squared, whereas the BT 2.0 connector has an electrical contact surface area of around 12.6 millimeters squared. So over 50% more, which effectively means that there's a lot less resistance and a lot more power is able to pass through the connector more efficiently. In terms of design, you can think of these BT 2.0 connectors very similar to like a tiny XT30 or XT60 connector, which is quite a bit more common in the FPV hobby, with the larger 2, 3, 4, 5 inch up to 7 and 9 inch quadricopters. And along with having more electrical contact surface area, the prongs are also thicker. Overall, it's just a more stout connector, which improves performance but also just makes it a lot more durable. So your chances of bending the pins go down quite a bit. Chances of cracking the connector, which I've done in the past, go down quite a bit. It's overall much more rugged, much more durable, can handle crashes a little bit better. And if you're swapping out batteries constantly, which is pretty normal for the FPV hobby where you're only getting a couple minutes of flight time, it makes your experience with the connector just overall quite a bit better. While this BT 2.0 connector is better in just about every way compared to the PH 2.0 connector, there are a few advantages of the latter. those being pricing and availability. So the BT 2.0 connectors have only been out for a couple of years now, so it hasn't had a ton of time to catch on and become really, really popular in the FPV hobby. These are also connectors really only reserved for tiny whoops and small toothpick style drones. So the connector hasn't caught on quite as fast as it would have if it was, you know, the entire FPV community. This just means that your battery options are a little bit more limited and tend to be a bit more expensive. Beta FPV sells some BT 2.0 batteries. The Tiny Whoop brand Tattoo sells some Tattoo R-Line batteries. So there are some really great battery options available, but you're a little bit more limited in terms of availability, and they tend to be priced a little bit higher because of that. Along with that, there's a good chance you'll need to make some modifications to your quad in order for these batteries to actually work. Mainly just swapping out the battery lead, but it will require potentially some soldering and disassembly of the quad. So there's a little bit of legwork that goes into it, but the results I found to be quite good, so in my opinion it's worth doing. Disclaimer, I am by no means a professional with the soldering iron. I know just enough to be able to do these projects and kind of get by. Try not to judge me too hard, but also if you're at all interested in learning how to solder or taking on a project like this, it's a good idea to go ahead and check out a YouTube video or a couple of YouTube videos that shows you how to solder, teaches you some of the techniques. Don't necessarily look at what I do and assume that that's exactly the best way to do it. But now that we know all we need to know about the differences between the connectors, let's go ahead and start getting this bad boy ready to fly on some new batteries. All right, first things first, we need to remove the canopy from the quad. There are 4 different screws, one on each corner of the canopy. Once we get the canopy removed, that'll help us get access to some of the electrical components that we need to work with and some better access to remove the board so we can get to the battery lead. These screws are tiny, so make sure you keep them in a safe place, don't lose them. On my Mobula 7, the solder pads for the battery lead are labeled BAT for positive and ground for negative. Next, we need to remove the AIO flight controller and ESC board from the frame. In order to do that, we have to unplug the FPV camera and all the motor connectors. You can see I'm using a set of helping hands here just to hold the board while I do the soldering. Super helpful. You can get them real cheap on Amazon. I'll have those linked in the description as well. Step 3 is to remove the old PH 2.0 battery lead. This just involves melting the solder that's already there and pulling out the lead. And before we go any further, I want to apologize for any focus issues that happen or portions of this recording where my head sneaks into frame. I'm still fairly new to the whole top-down camera thing. The blue cable is the positive cable and the white cable is the negative cable. Step number 4 is to solder the new BT 2.0 battery lead into the AIO board. I was able to get the positive lead in super easily, but for some reason the negative lead was giving me a lot of trouble. So you can see here, I had to switch to a new set of leads. And the second set I was able to get in just fine. Here's the finished product. Actually looks not too bad if I do say so myself. Next, we're just going to be reassembling the whole thing, starting with the motors. I'd recommend using a pair of tweezers or pliers for this, but I was too lazy to get some, so I resorted to using a little flathead screwdriver to snap the connectors in place. Your next step is going to be reconnecting that FPV camera. And then finally we can reconnect the little UFL antenna and the canopy. Good thing we didn't lose those screws. here's what she looks like all said and done. And we're going to give it a test with our new BT 2.0 batteries. These are the Beta FPV Lava 450 milliamp hour batteries, and it works. And now for the charging board. Now, in order to get the BT 2.0 connectors onto the parallel charging board, every board will vary slightly. This board in particular, the Happy model parallel charging board that came with my Mobula 7, has 4 screws that need to be removed, 1 in each corner. Then the circuit board will pop right off. I'm going to get the board set up on my helping hands. And I decided to pre-tin all the holes that we're going to be using. If I did this again, I may not have pre-tinned them just because it made it a little bit more difficult to stick the connectors through the holes. I may have been better off just soldering them in once the connectors were fully through, but you live and you learn. One thing to keep in mind is it's really important to make sure that the positive and negative sides of the connector are correctly placed. My board had it labeled based on the size of the connector, but just make sure that you get that right, otherwise you're going to deal with some issues when you go to connect your batteries. Also important to keep in mind, only use as much solder as you really need. If you over solder the connectors, it's not hard for the positive and negative solder terminals to bridge. That'll cause you some issues for sure. Obviously, my work here isn't too clean. The connectors are a little uneven, but they're connected, the electrical connections are good, and that's all that matters. I'm going to go ahead and get the circuit board screwed back in here, and we'll take our first flight. All right, so we got everything swapped out on the drone, the new connector, and we've got the new batteries. We're going to go ahead and take a maiden voyage. Before we get started, a couple things to note. The big thing is these are brand new batteries. These are the Betaflight Lava LIHV 450 milliamp hour batteries. So I'm going to be comparing these softly to batteries that I had previously with the PH2 connector, just because these are new. So obviously there's going to be some flight differences between these and my older batteries because they're brand new. It's not entirely the connector, but I'm going to be keeping that in mind when I note some of the differences between the batteries. The main differences I'm expecting to see are quite a bit less voltage sag. I think that's the big thing that this connector offers over the PH2 connector, because it's going to maintain its voltage during flight a little bit better. And then the other thing is potentially a little bit more power. This connector is capable of a little more power delivery during flight, so I don't anticipate necessarily seeing like much higher max speeds, but potentially the ability to throttle punch and pull out of turns and pull out of flips and stuff like that a little bit better. Excuse the dogs barking. They're all going crazy over nothing. Let's get to it. Well, immediately I can see that we may have an issue because I didn't calibrate the battery on Betaflight. So I'm immediately getting land now messages, but I'm just going to take a look at the voltage and be comparing that. And right off the bat I can see quite a bit less sag. Oof. Yeah, significantly less voltage sag. I'm usually getting low battery warnings here with voltages around 3 point. Sorry, it's hard to talk and fly, harder than I expected. Yeah, my voltage hasn't gone below 4 yet, which is pretty amazing. Normally I'm getting voltage drops to like 3.2 when I throttle punch hard. Granted, like I said, I'm comparing to some older batteries, but it's pretty obvious. That's a throttle punch, and my voltage dropped to like 3.7, 3.6. That was full throttle. I'm not flying terribly aggressive, obviously. Kind of a warm-up pack, but also the sun is shining straight through, and with this little analog tiny whoop camera, sometimes it is kind of hard to see when the sun's shining through. But I mean, so far, I'm really impressed. Yeah, I mean, that was probably an 85% throttle punch, and the voltage didn't drop more than 0.1, 0.2 volts maybe, which is really great for a tiny 1S battery like this. And I mean, like I said before, soft comparisons. I'm comparing to kind of older PH2 batteries, but no doubt about it, flight time is quite a bit better than what I was getting before. These Betaflight Lava batteries are the folded LiPos, folded 1S LiPos. So they are the better battery technology, at least for 1S that's out right now. Similar to some of the Tiny Whoop branded batteries and the Tattoo R-Line 1S batteries. But I mean, I'm really curious to see once I do land what the flight time's gonna look like, and I would love to see how much the voltage is going to come back up after I land. Because obviously with that much less voltage sag, you're gonna be able to fly much closer to your desired end voltage, which for me is usually between 3.2 and 3.5. I like to hang around 3.5, but you can push it a little bit. Yeah, I mean, nothing really too fun flight-wise right now, so I'm gonna go ahead and land and see how long that flight was. Oh, we're coming in hot. Yeah, I mean, voltage spiked back up to 3.75, and that was 4.5 minute flight time. So you can definitely get some more flying out of there. Flying like that, I could probably get to, I don't know, probably get around 5.5 minutes flying like that. Maybe 6 if I really pushed it, but at the same time, I can fly pretty hard and probably get 4-minute flight times, it looks like, which was not the case with my last batteries. All right, so after flying a few packs with my Happy Model Mobula 7 1S on some Beta FPV Lava 450 milliamp hour BT 2.0 batteries, I'm pretty excited about the results, to be honest with you. I expected to see some improvements in performance when it came specifically to voltage sag. I didn't quite expect them to be that good, but they are significantly better than the PH 2.0 batteries I've used in the past, and there's no doubt about that. I also felt like my flight time was quite a bit better than I expected, so that was an unexpected win for sure. Overall, definitely a big performance improvement. The big difference, like I said though, is in the reduced voltage sag, which in my opinion is enough to justify doing the work on the quad and your parallel charging board and all that stuff to accept the BT 2.0 connectors. My hope is that the connector continues to become more and more popular as it ages, and more companies start to release batteries with the connector and prices start to drop and it becomes a little bit more accessible. Ideally, more and more quads will be released with this connector stock instead of the PH 2.0 connector. But we'll have to wait and see kind of how that plays out. That's all I've got. Thank you guys so much for watching. If you did enjoy the video, definitely be sure to leave a like. If you enjoyed the FPV style content, I'd love to make more of it, so definitely leave a comment down below if there's specific things that you guys are looking to check out. Thank you guys so much for stopping by. If you want to see more similar content to this, hit that subscribe button, and we will see you in future videos.